So we are graphing this one, which is the reflection of this parent graph. Let's continue. Domain will be all real numbers. Range, try to pause this video and answer these questions. Try to engage in the video, do not just listen. Okay, it's going to get so boring to listen to this. Okay, try to engage. Range will be negative infinity up to 0. You see that? Negative infinity to 0, not including 0, and our asymptote will still be the line y equals 0. Next. Okay, so next it will be this. We're going to graph this one now. Okay, for the next, y is equal to, let me get a clean piece of paper. Okay, we're going to get y is equal to 3, 2 to the x. Okay, 3, 2 to the x. So we say this number here will vertically stretch the parent graph by a factor of 3. So stretching vertically means we put the points farther away from the x-axis, okay, by 3. We are not translating, we are expanding. No, we are, yeah, vertical stretch. So this is our parent graph. Okay, so we're going to stretch this. Let's remove this so we don't get confused. Okay, so we're going to stretch these points. Okay, 3, factor of 3. So this distance here, you see this, how far it is from the x-axis. We're going to get 3 times of that, but starting here. So 1, 2, and 3, it will be here. Okay, let me just get a new one because it's going to be too complicated and too crowded there. So let's start here. Okay, let's have a new one. Okay, with the parent graph. So that is our parent graph. Let's start. So we're going to stretch this vertically by a factor of 3. So this is 1. That's 1 distance. 2 and 3. That is stretching vertically. Okay, so that's the new point. This one is this length, 2 and 3. We always start with the x-axis, and this is 1/2. So 2 and 3. So it's going to be there. So that will be our new. And then, okay, let's go. We cannot stretch this from 0 because it's already on 0. So that will remain our asymptote. So you see, this is the stretch graph, and we will approach 0 just the same. Okay, so just try to approach it like that. Okay, so asymptote is the same. So this is the graph y equals 3, 2 to the x, and our domain here will be the same. Range will be the same, 0 to positive infinity, the same as the parent graph, y equals 2 to the x, and our asymptote is the same, y equals 0. Or maybe we should also get our y-intercept. Y-intercept is 3. Okay, you can see that. So y-intercept is y equals 3. This is a line, this is y-intercept, or we could say 0, 3. Okay, let's go to the next. What if we put 1/3 instead of 3? That will shrink it by a factor of 3. So we have to divide this original distance by 3. Okay, so if you have, so maybe somewhere here like that. Okay, you just sort of approximate. So we divided this by 3, or you can multiply the y by 3, but it's up to you, by 1/3. Okay, so your graph is, what are our y values when x is 1, y is 2, when x is 0, 1, and negative 1, 1/2. You can just multiply all of this by 1/3, but I'm just sort of looking at the distance by transformation. So this will be 2/3. Okay, here, somewhere here is 2/3 too. Okay, so I'm just going to use that, and I'm going to divide this by 3, so 1/3, and I'm going to divide this 1/2 by 3. Okay, just by looking at the graph, approximate it's here. Actually, it's 1/6. You can see here it's 1/6. Okay, and this is 1/3, and this is 2/3. But you can see that by approximating, looking at the parent graph. Okay, so this is our graph. This is still our asymptote. Okay, because it's on 0, it doesn't change. So this will be our next graph. It will still go up, and it will approach 0 there. So this is y equals 1/3 2 to the x. Domain is still the same, all real. Range same as the parent graph. Asymptote is the same, y equals 0, and y-intercept is now 1/3 0. Or you could just make here x is equals to 0. How do you find the y-intercept? You make x 0, so this is 1, 1/3. But if you have the graph, you just look at the graph. Okay, the point, or you could just say y equals 1/3, but it might look like a line, so just give the point 0, 1/3. Okay, let's go to the next. 2 1/3 x. Okay, so the new equation is 1/3 is not multiplied to 2 to the x, but 1/3 is just multiplied to, no, but 1/3 is multiplied to x, not to the parent graph. So 2 raised to 1/3 times x. Okay, what's the difference between these two? Okay, this is vertically, this is horizontally. But now in this graph, since we only have to get the basic ones with our video lessons because of this online thing, I'm not going to give horizontal transformations again, but I just want to show you one time. Okay, we're just going to concentrate on vertical stretch and vertical shrink. So we're going to continue this on the next video.